So the first one is that a plus b times a minus b, similar to the warm-up, equals a minus b squared. Okay, so the first special property of the same numbers each other's, but they have all times a squared minus b squared. Okay, and this application, if you ever do something like 102 times 98, you can actually make this a lot easier, but we'll talk about that in a sec. For us, for factoring, you can actually, an example problem might look like this: x plus 3 times x minus 3, right? X plus 3 times x minus 3 might be an example problem, and we would already know that it would be the first thing squared, so x squared minus, and then 3 times 3, or 9, right? 3 times negative 3 would be 9. And again, this makes sense because if we FOIL, or we multiply out to distribute the numbers, then this is going to be x times x, so x times x. So again, we would do first, or multiply the first two things in the parentheses, so x times x, and then we would do x times negative 3, so outside it would be plus x times negative 3, and then we would do inside, which is 3 times x, so plus 3x, and then we would do 3 times negative 3, so that would be plus 3 times negative 3. This will equal x squared minus 3x plus 3x minus 9. And you can see here that when you have alternating signs with the same number, those two numbers will always cancel out in the middle, right? So with just one variable, they will cancel out, and you're left with the x squared and then the number squared. Okay, so that's just the pattern that we see. So if you see a problem where it's like x squared plus or minus a number here, or sorry, just minus a number, then we can go ahead and use this identity, right, to go ahead and factor it out like this. Okay, so this is just one of the type of problems we might be introduced to. Most likely you'll see something like this, and they'll ask you to factor it. If you want to kind of understand what's going on here, this is x squared plus 0x minus 9. So if you were to use the diamond method, again, just to organize your stuff, it'd be negative 9 and 0, and you would think about what two numbers when multiplied equals negative 9, and what two numbers when added together equals 0. Okay, so mathematically that's what we're doing, but again, this is just a pattern that we see. An application of this, again, on higher math is just, you could just do 100 plus 2 times 100 minus 2, and then this would just be 100 minus 4, and then you could easily just do multiplication. It could be a cool party trick. But again, this has effect in when you're doing GRE. They'll throw problems at you where they ask you to multiply big numbers, and actually what you're supposed to do is you're supposed to split it up into, you're supposed to apply this pattern, and then that's really what happens there. It's very interesting. So this is actually a faster way of multiplication. Again, it's very interesting. Okay, does anyone need more time on this? And again, this part right here is just more of like a fun fact. You won't really use this until you have to take your graduate tests, but that's even after college, so don't have to worry about that. Just a fun thing that you could use. Okay, the second product is if we have a minus b times a minus b. So essentially if we have the same thing, but we have a minus b times a minus b. This is always going to equal a squared minus 2ab plus b squared. So actually, let me give you guys a harder problem here. So as an example, you might have something like 2a minus 3, 2a minus 3. And what this is going to equal is 2a squared minus 2 times 2a times negative 3 plus negative 3 squared. The reason I'm putting it in this form is because we're actually going to usually see it from the other side, which I'll show you. 4a squared plus, in this case, oh, actually this should be minus 2ab, 2a, oh wait, yeah, sorry, this should be plus. So this is 6, 12, yeah, sorry. Excuse me. Sorry, I accidentally put in a negative. I shouldn't have put a negative. That's why I was checking. And then plus 9. Okay. So usually you'll be given a problem that looks like this, where it'll say 4a squared minus 2a plus 9. And they'll ask you to factor it. And what we're going to use is we're going to use this identity where you can break this up into this portion, which is a squared minus 2ab plus b squared. Okay. So usually we're coming from this side where we're given the problem 4a squared minus 12a plus 9, and you actually want to just go ahead and look at, you know what, this would be a squared, and you look at this one would be b squared, right? So then we break it down, we think about what times what would equal 4a squared. So 2a times 2a would equal 4a squared. And then here we want to think about what times what equals 9. And since this is a negative in the middle, then we would think about two negative numbers times each other equals the number at the end. So we can square root this and it becomes negative 3. We can input it in the middle. So we can divide this by 2 and then put, again, the a's and b's here. And then we can go backwards to find our roots here. Okay. And again, this is an application here. You could also think about, like, from here to here, you can think about what are the factors here. And again, that's more of an intuitive way. But what I want to show you is that you can use this identity to go, again, from the product, and then you go to the factors. Okay. So one thing I just want to show you is you can go from the product to the factors. Okay, that one might seem the most complex, and we'll revisit that over the next few days. And then lastly, what we have here is we have a plus b times a plus b. And this is actually the same thing, except with the plus sign. We have a squared plus 2ab plus b squared. Okay. So you can actually apply this same thing to this same problem, except only if there's a plus sign in the middle. But we'll go ahead and show you a less complicated one here. Or actually, we'll show you a complicated one because you're going to need it. So as an example, if you have 3a plus 1, or sorry, 3x, you can use x or a, it doesn't matter, 3x plus 1, and this equals, again, 3x squared minus, or sorry, plus 2 times 3x times 1 plus 1 squared. We have 9x squared plus 6x plus 1. So again, what I'm doing here is, again, I'm just filling out the a squared plus 2ab plus b squared. And then I'm looking here, I know that a is my 3x. And then I know that b is my 1, and then I'm just going ahead and substituting into the different letters. So I'm replacing all the a's with 3x, and I'm replacing all the b's with 1. Okay. So again, what I'm doing is I'm just looking for all the a's, I'm replacing it with 3x, and then I'm replacing all the b's with 1. And then I'm filling out this formula, and I'm going here. The reason, again, is that sometimes you're going to be given an equation like this, and they're going to be asked to factor. And what you want to think about is, how do I use my product rules to go backwards? Okay. How do I use my product rules to go backwards? So what you want to do is you know that these are a squared you know this one is b squared, so then we want to use that to fill in our formula. Okay. So again, we look at these, we look at the a squared, we look at the b squared, and we can use this to go backwards. Okay. And again, we'll revisit this over the next few days. These are probably the most confusing concepts of this chapter. Okay. These two things are probably, I would say, the most confusing things about this chapter. So if you're getting confused on that, no worries.